Learning Target 18, Day 2, we're going to take a look at writing an equation given 2 points. Now we can write an equation given 2 points using only slope-intercept form, but I like using point-slope form for a couple of reasons. One, when you use slope-intercept form, you end up having to solve for b first, or the y-intercept, and a lot of students think once they have b equals, they're done, and they forget to put it back into the equation. Whereas when you use point-slope form, once you are done simplifying for y, you're done. You don't have to think about an additional step. Plus, with point-slope form, you substitute right into the equation initially, and slope-intercept form, you don't do that. So I just think it's much easier to use, which is why we didn't learn how to write an equation with 2 points using slope-intercept form. So, in order to use point-slope form, we need a point, which we have, and a slope, which we do not. So that's our first step, is calculating the slope. Now remember, slope is change in y over change in x. So think about when we did our sequences and we went, what value are we adding to -2 to get us to +4? And we are adding 6, so that's our change in y, over change in x. What are we doing to our -1 to give us a +2? And we're adding 3. So 6 divided by 3 gives us a slope of 2. Once we have our slope, choose either point, substitute it into the point-slope form or the asylum equation. I'm going to use 2, 4 because they're positive, and it's just easier to keep track of positives than negatives. So jotting down our point-slope form or our asylum equation, and then substituting in. We've got our slope is 2. I chose 2, 4. 2 is normally positive. When it goes inside the asylum, it becomes negative. 4 is outside the asylum, so it stays positive. And then we just go ahead and solve for y. So I'm going to start by distributing my slope. Remember to distribute your slope only into the parentheses, not to the value on the outside. And then combine your like terms. -4 plus 4 is 0. So we have the equation y equals 2x. We're just practicing the same topic over and over. So again, given 2 points, I'm going to start by writing my slope, change in y over change in x. Change in y, to get from 3 to 0, I subtracted 3. So my change in y is -3. Over change in x, 4 to -2, I subtracted 6. So when I simplify that, remember that a negative divided by a negative is positive. So I'm going to cancel my negatives and simplify my 3, 6. Dividing them both by 3, I get 1/2 for my slope. Choose either ordered pair, substitute into the asylum equation. And this time I'm going to go ahead and choose my -2, 0. Even though it's got a negative, it has a 0, which is even easier to use. So my slope is 1/2. My -2 is normally negative. I put it inside the asylum, it becomes not normal or +2. Adding or subtracting 0, since 0 isn't positive or negative, that doesn't matter. Distributing my 1/2. 1/2 times 2, or half of 2 is 1. And when I add the 0, that doesn't change. So that was my step 3, simplifying and solving. As I mentioned, same process. We just need to see a lot of different examples because the more you work with fractions, the more complicated it could get. So this one's a little bit harder than the last one. So calculating change in y over change in x again. How do I get from -5 to -4? I added 1, so that's my change in y. To get from 2 to 6, I added 4, so that's my change in x, which gives me my slope. Choosing either ordered pair, substituting it into point-slope form or our asylum equation. My slope is 1/4. Choosing either ordered pair, in this case it doesn't really matter. But when I look at my slope of 1/4, I'm looking at my 2 x coordinates. I've got a 2 and a 6. neither one of which is divisible by 4, which I'm going to have to do once I distribute. So I think I'm going to go with the 2 just because it's a smaller number and it might be easier to multiply by 1/4 by 2 than by 6. My 2 is normally positive, it goes inside the asylum as negative. My -5 goes outside the asylum and it's normal, so it stays at -5. And now we have to solve for y to put it in slope-intercept form. So I distribute my 1/4. 1/4 times 2 is 2/4, which simplifies to 1/2. And now I've got -1/2 minus 5. So I've got to subtract these fractions, or my fraction and my integer. So I'm going to turn this into 5/1 and find a common denominator, which is 2, multiplying my 5 by 2/2. And finally combining my like terms, -1/2 minus 10/2 is -11/2. We've got a couple more examples. I think these will go a little bit more quickly. Same process, change in y over change in x for our slope. My change in y from -3 to -3 is 0. My change in x from 3 to 6 is 3. 0 divided by 3 is 0, so my slope is 0. So a couple of things you need to remember. If the slope is 0, your equation is y equals. Look at our two-ordered pairs. My y equals -3 in the first ordered pair, and it equals -3 in the second ordered pair. So there's my equation, y equals -3. If your slope is undefined, your x values won't change, and you'll get an x equals equation. So let's take a look at our last example, calculating our slope. Looking at my change in y, -1 minus 3 gives me the -4, and my change in x is 0. Now thinking about -3 divided by 0, what that means is how many times does 0 go into -3? And we can't answer that, which means our slope is undefined. Dividing by 0 is undefined because it's not possible. So this was that second example we were talking about. If our slope is undefined, that means our x value doesn't change. So looking at our two-ordered pairs, x equals 8 and x equals 8. So that's the equation of our line. And your 2U-try problem.